Is the first question. It's question 11. So it asks me to derive a formula in terms of r and theta radians for the area of the minor segment under the chord BC, and hence find the ratio of the area of the major segment to the area of the minor segment subtended by the angles of pi over 2 radians. Right, so the circle looks something like this, and what I have is I have this part here is shaded in, and I have this here as my center, this is my radius, radius here, and this is C, this is B, and we have here, this is theta. Okay, so radius, right, this here outside here, that's my major segment, and down here that's my minor segment. Okay, so the first thing that I'm going to do is I'm going to get the area shaded is the area of the sector minus an area of triangle. Okay, so the area of the shaded, so this part here is an area of a sector of a circle. So if we look out here at the small sector, take away the area of triangle inside here. Okay, right, so the area of the sector here in radians is going to be half r squared theta. Okay, minus then the area of my triangle, so we're using the formula half AB sine C, so half the side is r, the other side is r, so that's where I get my two r's from, sine the angle in between, it's theta. Okay, so then what I have here is I have half r squared, I'm after taking out because a half r by r will give me a half r squared, so I'm taking out my highest common factor, so I'm left with half r squared, left with theta here minus sine theta, and that's that there. Then I'm asked, okay, so when the angle subtended by the angle of pi over 2 radians, so I let theta is equal to pi over 2. Okay, so then my area of my minor segment is equal to half r squared pi over 2 minus sine pi over 2. Okay, so I'm just filling in up here pi over 2. So I'm left then, okay, so r squared over 2 is the same here, and I have pi over 2 minus sine pi over 2 will give me 1. Okay, so this is my area of my minor segment. Then I need to get the area of my major segment. Okay, so my major segment is basically, it's a full circle. Okay, take away the area of my minor segment. Okay, so my area of my minor segment is pi r squared minus r squared over 2 pi over 2 minus 1. Okay, so I have my pi r squared minus my r squared over 2 bracket pi over 2 minus 1. Alright, so then I'm going to be multiplying things out. Okay, so I'm left then with pi r squared minus pi r squared over 4 plus r squared over 2. I'm going to take out my r squared, so I'm left with r squared, r squared bracket 3 pi over 4 plus a half. Okay, so when I take out my r squared, and then what I have is I have my ratio, so my area of my major segment is to the area of my minor segment. So my area of my major segment, I get this answer which we just got there, so it's r squared 3 pi over 4 plus a half, and my area of my minor segment, which we got earlier, is r squared pi over 2 minus 1. And then what I'm left with, okay, so I'm going to divide across by r squared, and I'm left with 3 pi over 4 plus a half is to pi over 2 minus 1. Okay, because I want to compare the ratios, I'm going to get my common denominator to be 4 on both sides, and when I tidy up and I do my basic fractions, I get 3 pi plus 2 over 4, and I get pi minus 2 over 4 here. Okay, and then I have 3 pi plus 2 is to pi minus 2, and that's my common ratio. Question 12 then I was asked. Okay, so question 12, it basically tells me that 5 discs fit exactly into a rectangular frame of width 20 centimeters. Find the area of the remaining space of the frame. Right, so my shape is looking something like this. Okay, so this is 20 centimeters. I have 5 circles in here, 1, 2, 3, 4, 5. Your diagram in your book or in the PowerPoint is a lot better. Okay, so then if this whole way is 20 centimeters, I need to basically be able to find out what is the area of a circle and what is my area of my rectangle. So what I know here, okay, so radius, 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 radius. Okay, so the full way across is actually going to be 4 radiuses. So I go 20 divided by 4 is equal to 5. So then that is my radius. Okay, so area of 5 discs is 5 multiplied by pi r squared. My radius we just found out is 5, so it's going to be 125 pi. So that's the area of my 5 circles inside it. Then I need to get the height of my frame. Okay, so the height of my frame is actually going to be twice h plus r. Okay, so I've just drawn out another little diagram here. So the full way across is 20. This is one circle, this is one circle. Okay, right, so the circles are touching. Okay, so from here to here that's a radius, from here to here that's a radius, and from here to here that's a radius. Okay, so if I were you, I would be looking at the book or at the PowerPoint. There's a lot better diagrams there. Okay, and then I'm just going to call this my height here. I don't know what my height is, okay, but I just know that that's one part of my height, because we're doing half of the actual diagram here. Okay, so that's why we're going to be multiplied by 2 up here later on. Okay, so what I have is I do my Pythagoras theorem. I'm after making a straight right angle triangle, so it's a squared plus b squared is equal to c squared. So I have, right, my a, right, so here's my a is r to be squared, plus my b is going to be h squared, and my side opposite my right angle is going to be 2r is equal to 2r to be squared. So I have h squared is equal to 2r squared minus, I bring over my r squared because I want to find out what is my height. Okay, and then I get h is equal to 2r squared minus r squared is 3r, is going to give me 4, this is going to be 4r squared minus r squared, so that's actually going to give me 3r squared. So then my height is equal to root 3 r. Okay, so now I know that my height is equal to root 3 r. So then the height of the actual frame is going to be 2 bracket h plus r. So 2 bracket my h we just found out is root 3 r plus r. That gives me, then when I multiply things out, I take out my r in this case, so I get 2r, and I'm left at root 3 plus 1. And then I know that my radius is 5, so I just sub in for that and I get 10. So I get 10 bracket root 3 plus 1 is my height outside here. Okay, so now I figured out this and I know what this is here already. So then for this particular question, I get the area of the frame. Okay, so my rectangle is length by width. Okay, so this here we are already given at 20, and we've just worked out that this here is my height of the frame, so it's 10 by root 3 plus 1, and my answer that I get for that one is 546.41 centimeters squared. Then the area of the remaining space is going to be my area of the entire frame. Take away my area of my 5 circles, which we worked out earlier on, which was 125 pi. So my answer then for question 12 is 153.71 centimeters squared. Okay, so now we're on to question 13. And in question 13, I was told if the area of a sector of a circle is 48 centimeters squared and the perimeter is 28 centimeters squared, find the length of the radius. Okay, so I'm looking for my radius in this particular question, and I'm given enough information to go off and actually solve it. So an area of a sector is equal to half r squared theta. Okay, right, so I was actually given my answer. I was told that it's 48, and that's equal to half r squared theta. So then what I'm doing here, okay, so I'm going to multiply up by 2, so I get 96 is equal to r squared theta, and I have theta is equal to 96 over r squared. Okay, because when you look out over here in a few minutes, you're actually going to need to be able to fill in for a theta. Okay, so that's why I found out theta. Okay, the area perimeter is equal to, okay, so it's 2r plus r theta. Okay, so this is the area of the perimeter. So if we were getting the sector, so if I was looking at my sector, let's say here is my circle, and I was looking for just this particular part here, this here would be a radius, this here would be a radius, and this is actually my r theta. So that's where my perimeter is coming from, the area perimeter of a sector. Okay, so I get 2r, so r plus r, 2r plus r theta, and I'm told that this answer is actually equal to 28, so I go 28 is equal to, I take out my r, so I'm left at r bracket 2 plus theta. So I have 28 is equal to r bracket 2 plus, I figured out there up here that theta was equal to 96 over r squared. So then I'm going to multiply across by r squared, so I get 28 r squared is equal to 2r cubed plus 96 r. Okay, so then I have 96 r, and then I'm left with, okay, so I have 2r cubed, bring over my 28 r squared becomes minus 28 r squared plus 96, or is equal to 0. Now I'm just going to divide across by r, my common factor, so I am left with 2r squared minus 28r plus 96, and that's equal to 0. I have a quadratic here, and that's what I'm going to solve for my radius. So I'll solve my quadratic, and I'm left with 2r minus 12, r minus 8. So I'll get 2r minus 12 is equal to 0, so r will be equal to 6, and I'll have r minus 8 is equal to 0, and r is equal to 8, and that's question 13 completed. Okay, question 14 goes that a farmer has a shed measured 4 metres by 5 metres in the centre of a large field of grass. He ties a goat to one corner of his shed, and using a rope measuring 8 metres allows him to graze on the grass. Draw a diagram showing the grazing area. Indicate on the diagram the different sectors of circles represented by this area, and calculate the total grazing area correct to the nearest metre. Okay, so now we're going to go off and solve that. Okay, so first of all, I'm actually going to go off and draw my diagram. I don't have that already done out in the solutions because I want to do it here. So what I have, okay, so I'll have a circle, basically, like this. Okay, so I have his shed. Okay, so his shed, and that's going to be 4 metres, and here is going to be 5 metres. Okay, so from this point, okay, we're going to say that this is his 8 metres that he's actually allowed to wander off towards. Okay, and then over here, okay, is going to be 5 metres. This is his shed down here. Okay, right, so basically I'm having different sections of my circle being met. Okay, alright, so the first thing, okay, that we get is for part 3, okay, so we get the area of the different kind of circles that are after to be made. Okay, so we're kind of, this here is going to be representing like a quarter, and this is actually going to be representing 2/3 or 3/4 the rest of it. Okay, so the area of the first part, okay, is going to be because we are in a quarter, so its area of a sector is 1/4 pi, and my radius for this one is 4 metres, so it's going to be 4 to be squared. So my answer for that particular one is going to be 1/4 pi 4 to be squared, and that's equal to 4 pi. My next one, part 2, okay, so where we have 3/4 of the circle, okay, so 3/4 of the actual circle, so from here to here, after just making a quarter, the rest of it then has to be 3/4, and my radius is going to be 8. So I have 3/4 pi 8 to be squared, and that's equal to 48 pi. And then part 3, then I have 1/4 pi, because we're still in a quarter, but the radius for this particular one is just going to be 3. Okay, so I have 3 squared, and that's equal to 9 pi over 4. Okay, and then my total area is equal to, when I add all of those up, I get 170.43, and I get 170 metres. The reason why I had to take 3 as my radius for the last part of that circle is because I actually ended up using Pythagoras' theorem to actually find out what was the radius of the circle. So that's why I didn't use 5. So when I actually work out Pythagoras' theorem, I was finding out that my radius was 3 for my last circle, and that's why I chose 3 instead of 5.